Hello everyone. Today, I'm going to walk you through the phosphorus cycle on our Earth. Unlike the carbon or nitrogen cycles, the phosphorus cycle is slow and mostly sedimentary. Phosphorus is essential for life. It's a key component of DNA, RNA, ATP, which is the energy currency of cells and bones, but it doesn't have a gaseous phase, so it moves very differently. Let's explore this cycle. The phosphorus cycle connects rocks, soil, living organisms, and water bodies in a continuous loop. We'll go through each major stage clockwise. Stage 1. Weathering and erosion. Phosphorus starts in rocks, mainly as phosphate minerals. Rain, wind, and chemical weathering break down these rocks and release soluble phosphate ions into the soil. This is the primary source of phosphorus for terrestrial ecosystems. Stage 2. Uptake by plants. Plants absorb these dissolved phosphates through their roots. Once inside the plant, phosphorus is used to build essential molecules. This is why phosphorus is a critical nutrient in fertilizers. Stage 3. Transfer to animals. When herbivores eat plants and carnivores eat herbivores, phosphorus moves up the food chain. Animals use it for bones, teeth, and cellular energy. Stage 4. Decomposition and return. When plants and animals die, or when animals excrete waste, decomposers, bacteria, and fungi break down the organic matter and release phosphorus back into the soil, ready for plants to use again. This completes the terrestrial part of the cycle. Stage 5. Runoff and aquatic systems. However, not all phosphorus stays on land. Rain and irrigation cause runoff that carries phosphates into rivers, lakes, and eventually the ocean. In water bodies, aquatic plants and algae take up this phosphorus. Stage 6. Sedimentation and rock formation. In the ocean, phosphorus eventually settles to the seafloor as sediment. Over millions of years, these sediments are compressed into new sedimentary rocks. Geological uplift then brings these rocks back to the surface, where weathering begins the cycle again. This geological part makes the phosphorus cycle one of the slowest biogeochemical cycles. It can take thousands to millions of years to complete a full loop. Let's highlight some important facts. Phosphorus is a limiting nutrient in many ecosystems, meaning its availability often controls how much life an environment can support. Unlike nitrogen or carbon, phosphorus has no significant atmospheric component. It is vital for all known life forms. The cycle is largely one way on human timescales. We mine it from rocks faster than natural processes replenish it. Human activities have significantly altered this cycle. We mine phosphate rock heavily for fertilizers and detergents. Excessive fertilizer use and runoff lead to eutrophication, nutrient overload in lakes and rivers that causes harmful algal blooms, oxygen depletion, and dead zones. This is a growing environmental concern worldwide, especially in agricultural regions. Sustainable management of phosphorus is becoming increasingly important for food security and environmental health. To summarize, the phosphorus cycle moves this critical element from rocks, soil, plants, animals, back to soil, and eventually through oceans and back to rocks. While natural processes are slow, human intervention has accelerated the movement of phosphorus, creating both opportunities and serious ecological challenges. Understanding this cycle helps us appreciate why responsible fertilizer use and wastewater treatment are so vital. Thank you for watching. It is also our pleasure to introduce you with our newly developing indie game.